Okay, everybody. Welcome back to school. I'm Mr. Ball. We're going to start on our Unit 3, Nature of Electricity. Um, it will be a bit of a shorter class today, and then I'm going to get you guys into kind of an instructional video on how to use these PowerPoints and use these videos properly to get the most out of them. So it'll be a short thing today, but there will be a second video I want you guys to watch. I'll post it along with this one, and it'll kind of teach you how to use these properly. So to get started, we're going to watch a video. Um, when you are watching these two demos, I want you to think about why the styrofoam plate is floating and why does the can roll towards the tube, and also how. What are the mechanics behind that? What's causing them to move towards that tube or for the styrofoam plate to float? And you guys probably know the answer to one of those questions, but later on, probably in tomorrow's video, we're going to tackle the how. We're going to get into the mechanics and we're going to get into a model that we use to describe what's happening. But for now, just watch it, brainstorm, see what you can come up with. Okay, groovy. So what we want to get into before we start any of that stuff is just like in our chem unit, we got to talk about the old models of electricity. How did we get to the model that we have now? What are the kind of front runners of this uh, part of science get right? What did they get wrong? And what can we learn from them? So, excuse me. So early on, scientists figured out that you could charge objects, that objects could have something put into them that would cause them to repel certain other objects and be attracted to certain other objects. And this gave rise to what we call the fluid models of electricity. And there's two of them. The first one is by Charles Francois de Cisternay-Dufay. And he proposed that electricity was made up of two fluids with different charges. Just like fluids like water or gas, but there was some other fluid that caused things to be electrical. And he said that neutral objects had equal parts of a vitreous fluid and a resinous fluid. And later on, we would kind of ascribe these as positive and negative. So vitreous is positive, resinous is negative. So an imbalance of these would create repulsion and attraction. A neutral thing would have the even amounts. And here, we'll just switch it over so I can draw it for you. It'll be a little simpler. So the idea was if we have, let's say our red is our positive or our vitreous. He said if you have equal parts vitreous like this, that you would actually have a neutral object. Okay. And he said that if you had an imbalance where there was more vitreous than there was resinous, then you would end up with a net positive object. And lastly, if you had more resinous than vitreous, you would get a net negative object. So that was his idea. You had the two fluids, very similar to, or the positive and negative idea is very similar to what we have now, but the fluid thing's a little bizarre. So there was another set of scientists who you're probably familiar with. One of them was named Benjamin Franklin. That's this guy. And then the other one was William Watson, this guy. And they both came up with this idea independently, because before the internet existed, that's often what happened, right? Before people were in constant contact or could be in constant contact with one another and their colleagues, people came up with good ideas all the time, and oftentimes two or more people came up with the same good idea. So they kind of posited or put forward that the one fluid model was explained a little bit better some of the natural phenomena that were occurring. And their one fluid model stated that there wasn't a vitreous and a resinous thing. There was one fluid that created a positive and negative charge based on how much of that fluid there was. So what theirs kind of looked like was, oh, wrong one, sorry. What theirs looked like was this. We had only a single fluid. What color should we use? We'll use this color. That looks like electricity. And they said if there's a normal amount of this fluid, then the thing is, oops, then the thing is neutral. Okay. And if there's not very much of this fluid, then they said that it was negative. So they were kind of saying that the fluid was innately a positive thing. And if you didn't have enough of it, then an object would be negatively charged. And these were the guys who actually came up with, or I think it was Benjamin Franklin in particular, came up with the terms positive and negative. So this one here would be positive because it has an excess of the fluid. It's more than normal. So, is that it? No. We have old models of electricity. This is kind of our conclusion here. In hindsight, these models were bizarre. Okay, they were a little weird. With the knowledge we have now, they seem kind of obvious. But with the knowledge they had back then, they described what was happening very, very well. And even though they are slightly off, even though we know that now, they hit the nail on the head for two things. There are two charges, so positive, negative, vitreous, resinous, whatever they called them. They identified that there were two charges. And they identified in some way what we call now the law of attraction and repulsion. So like charges repel like charges, and opposite charges attract. They identified that some objects did this and some didn't, and also that you could kind of transfer a charge to certain things and then use that to repel or attract certain other objects. Okay, that's it for this one. A little bit shorter. Make sure you watch that second video. We'll go over how to take notes from this and how to, it's kind of a precursor to our study skills unit. Okay, cheers guys.